Deep in the forests of Oregon, hidden underground, there is a creature whose size, age, and biological complexity surpasses anything we are used to seeing in nature. It is not an animal, not a tree, but a fungus, Armillaria ostoi, also known as the humongous fungus. With an area of around 10 square kilometers, it is the largest known living thing on Earth and has been growing unstoppably for at least 2,500 years. This enormous creature exists primarily as an invisible network of fine fungal threads known as hyphae, which run through the forest floor like an underground network of roots. When we think of mushrooms, we usually imagine their visible fruiting bodies, the typical mushroom caps that sprout from the ground in the fall, but that's just the tip of the iceberg. The true body of a mushroom, its mycelium, usually remains hidden and can take on gigantic proportions. The story of Armillaria ostoi only began for science in the 1990s, when forestry scientists noticed that large groups of trees were repeatedly dying in a part of the Malheur National Forest. Investigations showed that there was an extensive fungal structure underground, which was identified as a single, coherent organism through genetic analysis. Until then, no one would have suspected that a fungus could reach such dimensions. But how does this creature grow so gigantic in the first place? The answer lies in its special mode of locomotion and nutrition. Armillaria ostoi spreads via rhizomorphs, root-like structures that enable it to penetrate the soil and find new sources of food. It lives on wood, more precisely on dead and weakened trees, which it penetrates by secreting enzymes that decompose the wood. While this is an effective way for the fungus to survive, it means the end for many trees. Armillaria ostoi is both an important part of the ecological cycle and a destructive pathogen that can change entire forest regions. However, this giant is not only a threat to trees, but also a fascinating object of research. Scientists are particularly interested in how this fungus has been able to survive for so long. What genetic mechanisms enable it to spread over thousands of years? Are there biochemical processes in its mycelium that can be used for medical or environmental applications? Initial research suggests that its enzymes could help in the decomposition of organic material, for example to develop more environmentally friendly degradation methods for plastics or pollutants. What does this mean for us? For one thing, Armillaria ostoi shows us that nature's greatest wonders often remain invisible. This giant organism continues to grow without most people ever having heard of it. Secondly, it illustrates that nature creates networks that exist for thousands of years and shape ecosystems. Its survival is a silent testimony to the hidden forces that shape and sustain our planet. Research is still in its infancy, but one thing is certain. This enormous creature will continue to pose many mysteries for us. Who knows what secrets the humongous fungus still holds, and what we can learn from it. Perhaps one day fungi will not only make forests more sustainable, but also our lives. And perhaps in future we will walk through a forest with completely new eyes, always with the thought that the largest living creature on Earth is thriving under our feet. The growth of this fungus is not limited to Oregon. There are also gigantic colonies of fungi in other parts of the world, indicating that we are still far from fully understanding the true extent of these organisms. Many fungi interact with their environment in ways that are still a mystery to humans. Their influence ranges from aiding plant growth to creating entirely new chemical compounds that may one day be used for medicines. What if fungi could not only influence our forests, but also provide the key to solving some of our most pressing problems? Some researchers believe that fungi will play a significant role in the biotechnology of the future, be it through the degradation of plastic, the development of sustainable building materials, or even as the food of the future. Their ability to break down complex organic matter and transform it into new forms is unique in nature. Furthermore, fungi such as Armillaria ostoi raise an exciting question. What does it actually mean to be an individual? Is a fungus that extends over several square kilometers and regenerates over thousands of years really a single living being? Or is it rather a network, a living system that goes far beyond our classical notions of biological units? One thing is certain, these amazing organisms will keep science busy for a long time to come. Perhaps in the future we will not only learn to understand them better, but also to benefit from them. And perhaps one day, a fungus like Armillaria ostoi will not only teach us how life works, but also how we can make our own future more sustainable.